You all like animals, right? Great, because I've got an equation for you that I'm not BSing about. The litter size that a mother produces in relation to that mother's age for a given animal is actually represented by a polynomial equation, most commonly either quadratic or cubic, but we're going to take cubic this time. And our animal of choice? The cassowary. Birds are dinosaurs, guys, but just look at this thing. Luckily, it eats fruit. Why should we care? Because these guys eating fruit is vital for reproduction of trees and healthy forests. These trees are not just going to hit up tinder and hook up themselves, now are they? Okay guys, so as I said, we're dealing with a cubic equation, so our graph, well the part we actually care about, is going to look something like this. I mean, yeah, there will technically be a negative part of the curve, but you know, this isn't fucking Avengers where we can go back in time to when the cassowary existed, so we only care about this guy right here. So, okay. So we're going to have the y-axis as L, and that's the average litter size per mother. And we're going to have the x-axis as A, which just means the age of the mother. So our equation is going to look like L is equal to A, big A cubed, plus B, A squared, plus C, A, plus D. Okay, that's pretty good so far. So let's give this Let's give this a shot. Another way to look at it is that our L, or average litter size, is also a function of A, right? So that would mean that DL over DA is equal to F of A plus DA minus F of A over A plus DA minus A, which is just DA, right? Okay guys, it's going to be hella long, but you're going to be really glad we did it, right? So what we have here is as follows. We're going to start with F of A plus DA. As I said, F of A is the following. Oh, pardon me, I forgot to put the equal sign. So what we have is A, little a should I say, A plus DA cubed plus B A plus DA squared plus C A plus DA plus D. Okay, nice and simple. That is this guy right here, right? All we did was substitute A plus DA in our A right here. So now we're gonna substitute just our A. So minus A cubed plus, let me put a bracket for simplicity, BA squared plus CA plus D, yeah, and over our DA. Oh my god, come on paint, don't bail on me. Okay, this looks complicated, but I'm gonna show you why it's not actually that complicated. So keep your eyes peeled, trust me, this ain't even that bad, trust me. So guys, you know in your books and your teachers, they tell you that you can differentiate each term like this guy, that guy, or that guy separately. It's true, and I'm going to show you how. So we can rearrange this whole thing that's going to show you exactly why you can do that. It won't make a difference to the answer. It won't make the answer wrong when you differentiate something. So here's what we've got. So let's rearrange it as equal to, just say equal to, A plus DA cubed minus A cubed over DA plus B A plus DA squared minus BA squared over DA plus C A plus DA minus CA DA plus D minus D over A. Yeah, and remember that these are changes, so all of these, anything where you have a differential minus the actual thing, like this, that, the minus, that all makes it a change. So all of these are D's. Oh my god, get your mind out of the gutter, guys. That is not even what I meant. These are all D's. Get your minds out of the gutter, for real. Okay guys, let's dive right into it. You see, You see this guy where I'm pointing out right here, this is a binomial expansion. So if we were to expand the whole thing out, our whole thing would look as follows. A, capital A cubed, plus 3A squared, DA1, plus 3A1, DA2, plus DA cubed, minus A cubed. From here you see, then one big line over it. So sorry guys, Microsoft Paint is a complete bitch. Sorry guys. Over DA. But here is where it gets interesting. I mean, I've said it a million times. I mean, it might as well be a drinking game right now, by now rather, that DA is tiny. If DA is as tiny as you can imagine or can't imagine, or as tiny as I said it would be, imagine how small these guys would be with DA times DA, or DA times DA times DA. That is actually why we can chuck these guys out, because they're so small and chucking them out would make no difference to the equation, like virtually no difference, and they just get in the way. So we're going to chuck these guys out like the pieces of reptilian garbage they really are. So where were we? So you can see here we have A cubed minus A cubed, right? So we can just cancel them out, which pretty much just gives us a 3A squared DA, pardon me, over DA. But you can see it from a mile away. You can just cancel this out, and now we have our answer. Let me rearrange that. Ultimately, what we ended up with was as follows: DA cubed over DA is equal to 3A squared, which is exactly what you would get in your textbooks. There you go. I've just proved differentiation for you. But if you want me to get into these guys, fine. Let's go right into it. So let's take this guy. Yep, let's take him downtown. So we would end up with B A squared plus B, remember this binomial expansion, A1 DA1. Oh, pardon me, that was a very silly mistake. Plus 2BAA1. Yeah. Pardon me, guys. Plus B DA squared minus the other BA squared over this one I'ma do till it's over. Pardon me. DA. So we can chuck this guy out because he's so tiny with the 2DA squared. We can chuck him out, we cancel out these two, and ultimately we pretty much end up with 2BA1. And that's the differential of this guy. I know you can't see him, but bear with me. This one, yeah, it's pretty much a no-brainer. Let's do it anyhow. Let's pick a nice color. Let's pick yellow. We have CA plus CDA minus CA over DA. These guys cancel out. This cancels out too, which is pretty much just CA0. And just, I don't even need to say anything, guys. This is D minus D over, pardon me, DA. I don't need to say anything. That's just 0. So, ultimately, let's round up all of our terms, right? I apologize if this is messy and it's going fast. It's a video. Apologies, guys. If you want something slower and more thought out and easy to follow, you can check my book out, which I'll talk to you about in a moment. So, ultimately, our end result of what we had up top is this. Pardon me. df of A over dA, where f of A is AA cubed plus BA squared plus CAD. Let me zoom in real quick for you. Yep. This guy right here, we're going to differentiate it. Okay. Yep. is equal to 3a squared plus 2ba1 plus c, I'll say a0, but I mean it's kind of obvious, plus the 0 from the d, and that's pretty much your answer. So I'm going to show it to you one more time. This is what we had right here. Now, differentiate it as you've learned how with your formula, and now I've just proved that it's true to you. There you go, proof of differentiation. Boom, you're welcome.
Oh, you could even say that differentiation is like finding genes in DNA.
I got royalty inside my DNA.
Hey yo, fuck off, Kendrick, this is my—
Bitch, sit down.
So guys, did you like what you just saw? If so, what if I was to tell you there's a whole A-level maths ebook that I wrote just like that? So the situation with that, guys, is that the year 2 chapters and the few mechanics chapters are completely ready, but I need sales to buy the images. So make sure you tell your friends, tell your classmates, tell your family, tell everyone, and let's get this thing going. The best part about it is that the book is dirt cheap anyway, but if you buy it before any year 2 and mechanics chapters are added, you avoid the price drop and you get them for free. Once again, it's going to be dirt cheap anyhow, because this book was made by a student for you students, and it was made with love. I mean, if you don't like it, which I'm totally sure you will, but if you don't like it, there's a 30-day money-back guarantee. So, yeah, let's get this thing going, guys. I hope you like what you see in the link below. Peace out.